Hey guys, welcome to our video for 1C.2. This is Mrs. Payne. This is going to be one of your longer videos. I'll try to make it as short and sweet as I can. Our math learning objective is classifying expressions as rational or irrational. That's one of our most important key parts, right? We're just choosing rational or irrational by calculating these sum and product. Remember, sum means plus, product means multiply. Okay, so we're going to add and multiply things to see whether they're rational or irrational. Our rules: if I add a rational number, right, so I have a rational number and another rational number, I will always get a rational number. If I add an irrational number plus an irrational number, I will always get an irrational number. If I add one rational number and one irrational number, I will always get irrational. Okay? Those are our rules. So, even as long as there's just one irrational number, it'll be irrational. Okay? The only time you'll get rational is when they're both rational. So this first section is just going to be quickly choosing just by looking at them. All right, we looked at what rational and irrational numbers were in our last video and activity. We're just going to be quickly choosing whether they're rational or our sum is going to be rational or irrational. Okay. If I look here, 5/8, a fraction, remember, is rational. 3/5 is rational. Having two rational numbers, we just said was rational. Fraction and a fraction, two rational numbers. That's going to be rational, no matter what the answer is. I just know it's going to be rational. Rational, a root or anything with a square root is irrational. So we are going to be irrational because we have a single irrational number. Our next problem, all right, I have irrational number because it has a square root. And a rational number, a fraction. It's okay that it's negative. Doesn't matter. It's a fraction. Even one. Since there's even one irrational number out of those, it's irrational. Looking at number 5. So I have a fraction which is rational and a root which is irrational. Again, as long as even one is irrational, it will be irrational. Finally, I have a fraction, so rational, another fraction, which is rational. So, two rationals are going to be irrational. All right, let's look at some examples of how to actually add these things together. Okay? If two numbers have the same root, remember, root is another word for that radical. You add the coefficients and keep the root exactly the same. Okay? So here, my roots are the same. I have a square root 6 and a square root 6. Those are exactly the same. So I am going to add my coefficients, 3 and 4, which is 7, and my root stays exactly the same. I say the 7 square root 6. Okay, 7 square root 6. Example 8. I have 9 square root 17 minus 9 square root 17. Again, these are the same, so I can combine them. I think about like terms. 9 minus 9 is 0. Square root 17. This is a special case. Anytime you have 0 times a number, it is just 0. So that's my final answer. This is the only time it will happen when you have a 0 on the outside. The whole thing will be 0. Now, deciding if these are rational or irrational. Okay? These were irrational numbers. I still have a root. That means it's irrational. 9 square root 17 minus 9 square root 17. Again, this is a special case. Usually I would say this is irrational, but because it became 0, 0 is a rational number. Alright, so here's a few more examples on the next page. There are. Alright, square root 11 plus square root 11. Again, my roots are the same, so I can add them. My coefficients, my numbers in front. Remember, if there's no number in front, it is just 1. So 1 plus 1 is 2. My square root stays exactly the same, square root 11. Example 6. Look at here. I have a square root 7 and a square root 19. Oh no, those are not the same. So my answer is just 5 square root 7 plus 3 square root 19. It's like terms. If you can't combine them, you can't combine them. Okay, so don't force things together. Now let's look at this. 2 square root 11, it has that square root. It's, I don't know why I put it rational, it's irrational. Same thing here, I have square root. That means it's irrational. Okay? It's only rational if there's no root plus in your answer. Looking at 11, there's three terms now. I still want to look for my like terms, my like roots. I have a fourth root 6, a fourth root 6. And if I look at this one, it's a square root 6. That is not the same. Those are not like terms. So I'm only going to combine these two. 5 minus 8 is negative 3. And then I have fourth root 6. Remember your base, or that root stays the same. But I still need my plus root 6. Okay, I still need to have that plus root 6 in there. Now, is this rational or irrational? I have roots, so it is irrational. Great. Anytime you have that radical symbol. All right, last example for this set, for adding and subtracting. Cube root 7, or 3 root 7, right? Those are the same, so I'm just combining my coefficients. 9 minus 3 is 6, and then I'm going to have the third root of 7. So 6 cube root or third root of 7. That's it for adding and subtracting with roots. Okay. Looking at my next section, I'm going to look at multiplying. With multiplying with radicals. A rational, right, so same type of thing. If I have a rational number and another rational number, when I multiply, they will always be rational. Always. If I have a rational number and I multiply it by an irrational number, it will always be irrational. Last one, if I have, ignore this that says irration, if I have an irrational number and an irrational number, when I multiply, this one is your trickiest one. I do not know if I'm going to have a rational or an irrational number. I could get either. So this is the case. Oh, by the way. This is your important case where you do have to think about it at the end. You can't just assume what it's going to be. And we'll work through how to do that. So again, real quickly, we're going to go through and just decide from what we know, our rules, whether these answers are going to be rational or irrational without doing them. Rational is a fraction. Rational is a fraction. That means it's going to be rational. Two rational numbers will always give you rational. Alright, number 2, I have an irrational number because of the root, and an irrational number because of, I have an irrational number because of the root and a rational number because of the fraction. This one is going to be irrational. A rational and irrational always makes it irrational, according to our rule up top. Rational, fraction, rational, fraction. It's going to give us a rational number. Rational is a fraction. Irrational, because it's a root, that's going to give us an irrational. Rational is a fraction. Rational is a fraction. That's going to give us rational. Rational because it's a fraction. Irrational because it's a root. That's going to give us irrational. Okay, so I don't even have to solve it to know what it's going to give us. We can kind of make those decisions right away. Let's look at some examples of how we actually multiply with roots. Multiply and divide. Alright, looking at example 13. Right, or when we're multiplying with radicals. Multiply the coefficients and multiply the roots. So basically how I think about it, multiply the 3-0 outside, multiply the inside. Okay. So, looking at example 13, I'm going to always start by drawing my root. I'm going to multiply the inside. I have a 10 and a 10. Give up the full clause. That's it. So we're going to 10 times 10. Now, what is 10 times 10? You can always use a calculator. Pull it up even. Right, 10, 10. Yeah, 100. Okay? Now, in my calculator, to check if this can simplify to a rational number or not, I am going to put it in my calculator exactly how it looks. Your square root button, this doesn't move easily. Your square root button is above your x squared. I have to hit Control and here. You can open this calculator on your laptop or use the handheld calculator. So I'm going to do square root of 100. That didn't look. It should be inside here. Press enter. I get 10. I wrote that in my calculator. I typed this whole thing in my calculator. So I just put 10. A lot of students like to leave the square root there. Once you type it in your calculator, the square root might go away. Okay, if you don't get a root in the calculator, don't write it on here. Looking at our next number, okay? All right, we have the outside of the root and the inside of the root, right? So we can multiply the outside, 2 times 4. And we multiply underneath our root, 3 times 2. Okay, you can always use a calculator. 2 times 4 is 8. 3 times 2 is 6. Then, I'm going to put this in my calculator. The square root of 6 is a decimal. If you get this word decimal, it means your answer doesn't simplify, and we're just going to leave it like this. Don't write the decimal. Just leave it. All right, looking at our next problem. Again, I want to multiply the outside. Don't have an outside. Multiply the inside. So, square root of 15 times 6. Again, you can always use the calculator. 15 times 6 is 90. I'm going to type that in my calculator. Square root of 90. And again, I get a long decimal. With a long decimal, I'm just going to leave it. I don't change it at all. Okay? Example 16. Even with cube roots, it still works the same. I multiply the inside. Cube root of 8 times 2. Okay? That's the cube root of 8 times 2 is 16. I can still type this in my calculator. The only thing you have to make sure of is control. You use this one over here for anything that's not just a regular square root. I need to type the 3 in and the 16. Cube root of 16. Again, that's a decimal. This is just my answer. Finally, with dividing, last two examples, we'll get through them real quick. It's the same rule. Divide the coefficients, divide the, this is the root. Like, oh, sorry guys. Divide the root. Okay? So it's the same thing. I just write one big root and divide the things underneath them. 27 divided by 3. 27 divided by 3 is 9. And in my calculator, I can type in the square root of, I don't know really what it's square root of 9. Okay? Which is 3. So then, since I got a whole number, I don't write the root anymore. I just write the 3. Same thing here. This is the square root of 85 over 5. When I divide those, I get 17. Square root of 17. I get a decimal. Okay? So, I just leave it how it is. It stays in the square root. Remember, whole numbers are rational. Anything with a square root is irrational. So, make sure you mark whether it's rational, it's a whole number, or a fraction. Irrational is the square root. Okay, so make sure you're looking for that. I am sorry for the long video. Go ahead and work on activity 1C.2.